Are you tired of having messy data storage folders? Well, here's a simple 3-step workflow structure that will automatically move, archive, and organize all your data files after they've been analyzed, so you never rerun files, overwrite your results, or have to guess on what's been processed. And this isn't just some process that I've cooked up for a YouTube video. This is the same file management structure that I developed while managing the Strength and Power Lab at one of Canada's Olympic training centers. We were running force plates and dynamometry with results being created every day and multiple teams and athletes testing each day. So today we're going to dive into the framework of that same system so you can apply it directly to your own data analysis and file management programs. As sports scientists, we're constantly juggling raw testing files, processed data, master files, and final reports. And at scale, when you're doing this across multiple teams and multiple days, even small organizational mistakes can compound quickly and throw you completely off. I've been in situations where I'm running reports for 3 or 4 different teams in a single day, and each of those teams have multiple athletes testing across multiple different tests. And I've only got a finite amount of time to be able to create the reports, make sure the analysis is correct, and get things out to the staff so they can make the decisions that they need to make. And without a clean workflow, you risk making mistakes, losing files, or duplicating work and wasting time. And this is why automation is so important. With a system like what I'm about to show you, my raw data folders only ever had raw data in them, and everything else is archived automatically, so that saves me the headache of trying to figure out what's going on at any given time. It means that I can trust the process and focus on the actual analysis. Conceptually, this framework is pretty simple. It has 3 automated steps that move, organize, and date stamp all your files as you analyze them. This framework is set up with guardrails as well, so it handles anomalies and safely saves all of your files so you know where they are at all times. But it's really just 3 steps to your workflow. Before we go through the 3 steps, we'll first take a quick look at the folder structure that I use. We have our main lab folder, which inside of it has different folders for each type of data that we're looking at. So we have our torque analysis, the process data, the testing session archives, and our master file archives. And the project is set up so that the folders indicate exactly what's in them, and there's no second guessing of what's been done or what hasn't been done because it's all date and time stamped. Now that we know our folder structure, we can then apply our 3-step automation process to the file management system, and we'll know how it works within the folder system itself. And each of these blocks of code solve a specific failure point that I've seen within lab environments in my own personal experience. The first block is really centered on finding and archiving the latest master file. So the master file is where all the historical data gets saved. And this section looks for the most recent master file, loads it into our R project so we can use it later, and it moves the older master file into an archive so nothing ever gets overwritten. And all of these master files are date stamped. Next, we move into our second step of the process, where we append today's results and save a dated version. So this part of the code appends today's testing results to the most recent master file that we just found in step 1. It then saves the new master file in our main folder with a date stamp, so we know when it was made and when it was most up to date. And then we also have our historical record in our master file archive that we can go back to if we need to. Our third step in this process is to move all the processed raw files out of the queue. So all of our raw data gets put into our main folder, and then all of our analyzed data files are then moved as they're analyzed out of the main folder into our processed torque data folder. Then we know that any raw data that we find in our main folder has not been analyzed yet. So there's no guessing if you've run it or not, or if you need to run it, or what's going on. You know if it's in that folder, it has not been run. So the key here is you understand what each block does within the process. You can then adapt this to your own projects. Even if you're not an advanced R coder, you can still apply the same concepts. First, we find, identify, and move the master file. Then we add our new results and create a new master file. And then we move our analyzed data once it's been done analyzing. It's analysis and housekeeping all in one chunk of code so that you don't have to worry about it and do it by hand. So now we'll do a demo of, as the code runs, what we can see happening in the background so that we can see how it works in real life and why it makes my life so much easier. The real key here with this framework is that it's not about a fancy code that you need to write and really extrapolate on. It's about building repeatable workflows that run in the background. It takes the guesswork out, and it's something that you can trust when you're tired, busy, trying to multitask, and are responsible for allowing other people to make decisions with the data that you're producing. This is when systems matter most, when decisions are made based off of them. If you're working with real athletes with real timelines and real consequences, systems like this aren't optional. They're what keep your work reliable. And this channel is all about building practical, real-world sports science workflows, from data organization and testing to analysis and reporting, based on what actually holds up in high-performance environments that I've been in and I've run. If that seems useful to you, feel free to subscribe, and I'll see you in the next one. Thanks for watching.